our topic experts panel for hydrodynamics this year. We're going to start the session off. Our four panelists are going to talk about who they are, what they do, perhaps how their job relates to how humans interact with the water cycle. So we'll go through that, and then we will open it up to a question and answer. So please be thinking of questions that we can kind of start the conversation with and have a little bit of a debate about at the end of this session, because it is fed off of all of your questions. I can start thinking of questions, but you know, that's me. I'm not a team. So a reminder, this session can run late. We set it up going into lunch just for that very reason, so that we can get as much interaction with our topic experts as possible. If at lunch you do need to get up and leave, if you could do that quietly, that would be awesome. And of course we don't mind, but I mean, why not stay and get extra information? That's never gonna hurt. So we have them captive, so let's get started. So go ahead and everybody introduce themselves, and then we'll get into a Q&A. Go ahead.
Good morning. My name is Sarge Green, and I work at the water programs at Fresno State.
Good morning. My name's Steve Haugen. I work for Kings River Water Association as the Water Master.
Good morning. I'm Chad Fisher. I work for the state of California in the Division of Drinking Water.
Hi, I'm Lisa Cohen. I'm with the City of Clovis. I'm the Assistant Public Utilities Director.
Okay, we're ready to go. First, I'm going to talk to you a little bit about the Fresno State Water Program, so you know a little bit more about where we are and what we do, and then a little bit also about some of the water activities on the campus. We have several of the colleges that have water-related instruction, and I participate in that to some degree. And then I'll talk a little bit more about what I do, and then ask you how you can help, or tell you how you can help. I've been in the water industry for over 40 years. I'm a scientist. I have a degree in hydrology, and I started my career with the Water Quality Control Board. Does everybody know what that organization does? Yeah, they regulate water quality. Very good. I was a senior scientist with them, and I had some very interesting times because I participated in regulating a very infamous number of environmental problems. One of them was Kesterson Reservoir. I was the senior scientist that worked on that, and it's where we had stored and evaporated some water from the west side of the valley that had a lot of natural elements in it that are of concern to especially waterfowl. We had waterfowl in western Merced County at Kesterson Reservoir that mutated. They didn't have eyes and beaks. It was horrible. And anyway, then I also managed Superfund sites, 2 of them right here in the Fresno area for water quality purposes. And I also then regulated other types of discharges, including other agricultural discharges, pesticide facilities, oil fields. So I had a very robust career for a number of years, and frankly, it wore me out. I decided to change careers, and I went to the water supply side. I was the general manager of an irrigation district here in central Fresno County called Tranquility Irrigation District. So I delivered irrigation water to the farmers, but I also delivered drinking water to the small community of Tranquility. And I'm going to let the other folks on the drinking water side give you a little more in depth about the ins and outs of drinking water. But irrigation water is obviously very important here in the San Joaquin Valley because it drives the #1 business in the San Joaquin Valley, and that's agriculture. So I'm particularly interested and or engaged in making sure that we continue to have enough water to have a robust agricultural economy. We provide the fruits and vegetables for the entire country. The programs at Fresno State, we have 3 colleges that have a strong interest in water. The first is the College of Agriculture, the Jordan College. They have a plant science program, and they have a lot of investment then in irrigation classes. And on occasion, I teach as a guest lecturer in both the undergraduate and the graduate courses to keep them narrowed in on the issue of water supply for irrigated agriculture, but water quality as well. So I do a little bit of teaching. I also participate in, we have a master's online program in water resources management that is managed by the College of Math and Science in the Earth Sciences Department. And that is global, although most of the applicants are from California. When we teach, we use Zoom, and I have people from Arizona, Utah, and now one from Florida. So we have a little bit of a reach here these days, and we try to grab new students for that. So if anybody's interested in a career change, we have an excellent program. The last is our civil engineering department, and it's probably the organization that's most invested in water. A lot of the civil engineers come out with a water resources management specialty in that program. So a lot of the consulting firms and a lot of the water people here in the San Joaquin Valley come from either Fresno State or Cal Poly. But we have an excellent program as well. So I'm going to talk a little bit about the specific organizations that we work with at Fresno State and that I'm part of. The first and the oldest is the Center for Irrigation Technology, and it is what it says it is. We are one of the leading organizations in the globe on testing and approving irrigation equipment. We have a picture of our testing facility, if you could pull that up, please. And it's math and science, folks. It's a lot of measurements to make sure that when you buy something, whether it's from Lowe's for your landscape or whether it's a giant gun type irrigation equipment, they've got these big ones that shoot out real far, or drip tape or anything like that, we do the certification to make sure that what you pay for you get. So it's our oldest organization, has been around since 1980. For my part, I am part of the second organization that formed at Fresno State. It's called the California Water Institute, and it was started by then Senator Costa, now Congressman Costa, as part of a bond measure back in 2000, and we started up in 2001. And the Water Institute is kind of the overlying organization now, and we handle water quality and water policy. That's what I work on, water policy and water quality issues here in the San Joaquin Valley. And water policy, let me tell you folks, is tough because we have a very diverse state. We move a lot of water around, and there's a lot of competition for it, and it's getting worse. The last organization is the International Center for Water Technology, and because we had so much experience with irrigation equipment, the industry, quite a few of them right around here are international, and they said, we'd like you to get into testing all kinds of other things. So the second slide is a picture of all the pipes and pumps and all the things that we can do. It's a full-scale hydraulics laboratory that can test just about anything related to water. So whether it's a meter, it's a toilet, it's a pipe, it's a pump, whatever it is, we can test it. And so we're fully internationally certified to show that something is also doing what it's supposed to do. We did the toilets for Metropolitan Water District. So we've got a little bit of everything that we can do in there. So between the two, we've got quite a reputation globally, quite frankly. The next thing is what I do. I write reports. So not only do you have to have the math and science, but you have to have the writing skills to be able to do what we do. And what I in particular do is, since my broad experience includes both water quality and water supply, I'm a water management specialist, and I am pretty much on loan or can be used by a number of different organizations. I've done reports for the Bureau of Reclamation, I've done reports for irrigation districts, I've done reports for counties, all on water management strategies that they need to meet the water needs and management needs of the 21st century. For example, the counties that I work with, Merced and Stanislaus, I help them write new ordinances for water wells in their counties that are compliant with the new Sustainable Groundwater Management Act. We have a new law in California that closes the water cycle. We used to just regulate, for the most part, how we move surface water around, and groundwater wells that are used by agriculture, cities, and individual homeowners in some cases were not regulated yet. But as the result of the recent drought, the time had come. We had overdrafted our groundwater so much, it brought it to everybody's level and attention, especially the legislature up in Sacramento. We now have a new law. So that brings the entire management picture full circle. So we're very busy trying to figure out how to tie everything together based on the hydrologic cycle. You've heard it as the water cycle from the top to the bottom. All pieces are now in a picture where we're trying to integrate them all together, whether it's forest fires that affect the water supply in the Sierras, or it's floods that move water out all the way to the ocean, or groundwater, or water uses. All of those things are now very important and have to be worked together. We import a lot of water, in fact, from the northern part of the state. The San Joaquin Valley doesn't have enough water, and there's large pumps up in the Delta, and that has been the subject of a lot of controversy and a lot of political fights and a lot of water management strategies. And it's hurt the San Joaquin Valley because we haven't been able to pump as much out of the Delta. The water has been reallocated for other uses. So that's one of the core big fights in California. So what's left? What can you do? Number one, conservation. When you brush your teeth in the morning, don't leave the faucet on. Okay, that's an easy one. Number two is understand that we have this very complicated system, and develop something like a robot that can help fix things, or to develop something that educate people on how to use water more wisely. And that's my part. Thank you.
Thanks, Sarge. I've got about a dozen slides here. I'm going to step up here and go ahead and demonstrate or walk through these. This is the Kings River service area. This area, just for some guidance here, Fresno's up here, Corcoran's down here, Kettleman City over here, Dinuba, Reedley out in this area, and then on up to the northern end, northwestern side is Mendota and Tranquility. That represents about 1 million acres of farmland. We deliver about 1.5 million acre feet a year on average to that location. This year we're going to be close to 3 million acre feet. In a very dry year it might only be 400,000 acre feet. So it varies a lot with time. There's a lot of challenges with those variables. The other thing that we end up with in here is you've got crops from trees to cotton to row crop. And I think Fresno County, they say there's 400 different crops that are grown in Fresno County alone. There's 3 counties represented here. So it's a huge variety of needs and tasks. Ultimately, everything I do is the delivery of water, the moving it from the Sierras to the various irrigation districts. And then from the irrigation districts, they're delivering it to individual growers, cities, and such. So next slide. So I'm going to talk about starting at the top of the watershed, how water moves down through the watershed, some of the technical challenges and political challenges we meet with each one of those steps and phases. And my organization, a little bit of background on myself. I'm a ag engineering degree. I have a degree in ag engineering from Cal Poly, San Luis Obispo. I'm a licensed civil engineer. Math, science, water, you know, all of that is important. I've been doing this for about 27, 28 years. I've worked on-farm irrigation. I've worked groundwater modeling. I've worked through individual farmers in a lot of different cases with districts on how to better deliver water to those individuals. Today I'm doing, in the past 15 years, I've been doing what I'm going to be talking about here. Okay, this map is the upper watershed. The map I showed before is the valley floor down this way. This is from Pine Flat, which is just east of town, up to the crest of the Sierras. You come up into this area, Bishop and Mammoth Lakes are just on the other side of the Sierras from us. But that's about 1 million acres as well. That area is represented in this map, is about the same size as the other map we just looked at. It's the snow, it's the rain, the precipitation that falls in there is what fills Pine Flat and is what delivered to the valley floor here is our primary water supply locally. In the San Joaquin Valley, there's some broader issues like Sarge was mentioning about the imports from Northern California. But here in Fresno proper, our water is from the Sierras, just east of town here. So next slide. Part of what we need to do with that watershed is we look at you know, one of the things we try to do is know how much water is going to come out of that watershed. It's measurements of how much precip occurs. We take measurements of the snowpack, and we were able to just sample certain areas. This is a very remote location. If you look at this particular slide, this is just a map of a flight pattern we take when we do our snow surveys. We leave out near Sanger, fly up almost to the crest of the Sierras, up into a place we call Bench Lake, and then back down. So all of these yellow thumb pins are where we're taking various measurements. Most of that's in wilderness. There's no roads, there's no access. They're very remote. Next slide, please. And when we fly up there, you see various conditions. 2013, we had snow on the ground at the end of January. 2014, the end of January, this particular site was completely dry. No snow on the ground. This is about 9,000 feet elevation. Next slide. This is a slide from this year. This individual, you can see where this tube is in the ground, and you can see this tube completely out of the ground. There was 155 inches of snow. You know, 2 years apart, we went from bone dry, you could kick dust, to over 12 feet of snow. What does that mean for water supply? You got to know what's coming down to be able to know when to release, how much water you have to plant crops that year. A lot of people rely on those numbers. Next slide. One of the other things we have is a number of remote sensors. This happens to be one from this year that was almost buried. These sensors take a lot of maintenance, a lot of technology. That's an individual has to go up there and program those. They have to maintain them. The design of those sensors are really important. The conditions they meet. In the enclosures during the summertime, they can be exposed to 130, 140 degrees Fahrenheit. In the middle of the winter, when they're exposed out of the snow, they can see temperatures down into minus 10 degrees Fahrenheit. Extreme range for most sensors. You know, we think about our computers, oh, I don't want to leave it in the car, I don't want to leave it next to the stove or next to the heater. These things need to be very robust. It takes a lot of time and effort to maintain those. That's the technical side. The policy side is accessing these. They're in the wilderness. The definition of wilderness is no mechanical access, no left evidence of getting to there, yet 90% of our snowpack sits in wilderness. If we don't know what's going on, we're flooding people out down below. We don't know what's going on. So it's a real challenge from the policy side as well. So I'm going to move my way on down the river. Go ahead, next slide. Let me back up for a moment. Water supply. Water's finite. We only have so much. It's either in the groundwater, it's in surface water, it's in the ocean, it's in a lake. We can't really make it. But one of the things that most of the Sierra watersheds are done is weather modification. Most people refer to it as cloud seeding. A couple of examples here of aerial cloud seeding, ground generators. This is a way to enhance the natural processes that are going on and maybe yield a little bit more water out of that for benefiting the area. It doesn't generate water. We can't make water. You got to have a cloud. It's only certain conditions where it works, but it is a way that we can help with our human interaction. We can actually cause some natural processes to yield more water for us. So next slide. So then you've got snow in the watershed, starts melting, heads down the rivers, above the reservoirs. We have no control over that. All we can do is monitor and know what might happen. Once we hit the reservoirs, now we have an opportunity to start to make decisions and influence how water is released, where it goes, what time it goes, and those types of things. So that's a picture of Pine Flat. It's the terminal reservoir on the Kings River. I should know which river I'm working for. So that's a point where we can operate. We can make decisions of what happens. Again, challenges here, technical. It's a facility. It's man-made. There's maintenance required. There's trash that needs to be pulled out of trash racks. There's gates that need to be painted. There's confined access locations you need to get into that are hazardous for people. So there's a whole bunch of challenges there, and just maintaining that. You've got sediment that can build up in the reservoir that reduces the size of your bucket. So lots of challenges there. Next slide. So then as we move on down, in our case, we use the river for conveyance. It has its own policy issues, its own technical challenges. If you, like Sarge mentioned, is the Delta, you have water that's moved down a man-made canal through the California aqueduct, man-made pumps, man-made canal, all of that. It has its own, a different set of technical issues, a different set of policy issues. But for us, we've got the river. As you move down through these distribution systems, you end up with all kinds of facilities and features. You got pumps. In this case, I'm showing a weir on the left side of this slide. You have dams, you have gates, valves, all kinds of different features and facilities to help you move water, direct it, divert it. All of those require maintenance. All of those require somebody to go operate or some kind of instrumentation to tell them what to do at what time to do it. So there's a lot of technical. From the policy side, you're interfacing with various regulators, various agencies. When you start dealing with a river, you're dealing with environmental groups. You might be able to be dealing with recreational groups. You've got folks that want more water supply. You want folks that want fish in the river. So there's a real policy interaction there. You start dealing with flood releases. You have people next to the river that you need to maintain a system to adequately move water through it, but they like that system beautiful for their backyard. But you're trying to keep water out of their house, out of their farm, out of their business. So that's where the interaction with, when we talk about flood control, flood releases, it's trying to manage that and reduce that risk and problem to the actual people. The other thing, I'll show this, you know, in this particular case, this particular weir was made probably about 90 years ago. This is debris that built up in about 2 days during the early part of the flood release this year. And it took about an 8-man crew most of the day to clear that. Next day, they're back out doing it again. So anything that can be done to help facilitate, help maintain, make these things easier, those are the kinds of projects that we need evolution on. And the challenge is, this stuff's expensive. It costs a lot of money to have 8 people out there for a day. Likewise, having the right amount of equipment or the right type of equipment to help fix those things is a big deal. Next slide. So then, we've got conveyance. You know, I've just kind of gone through the conveyance. We've got snow in the mountains, creates the water. We move it down through our system, through a series of rivers, canals, channels, pipelines, pumps. Well, as it's going through these systems, you got to know what's going on. So you got to measure it. And one of our big jobs in my office is measuring. Here's an example of a gauge that we have. This is actually up near Boyden Cavern on the Kings River up in the national park. So this measures water level. We can correlate water level to how much flows through there. Again, some of the sensors that we have out there. Next slide. Then you get down on the valley floor. This is not the best picture, but there's a flow meter in here. It's actually a little propeller down there spinning along and a little odometer on it. You can look at it. Looks like your car. If you've ever flipped your water meter box in front of your house, you've got one there. Same basic deal. Different scale, different size, different parameters to install, but equipment everywhere. And then in some of the open channels, we go out and we'll calibrate these where a person will actually go out here down below and measure how much water is going by through the velocity of the water. And there's a bunch of techniques of doing that. There's some really new, interesting, pretty cool stuff coming out. It's not necessarily proven yet, but it's some pretty interesting things that are coming out and being developed. So next slide. Okay, now we got all these measurements. This guy took this much water, that guy took this much water. That's neat. What do you do with it? We also do the water accounting. So we plug all these numbers in, and basically we're tracking how much water a person is entitled to by, in our case we call it a schedule, but it might be a contract, it might be the city, it might be an irrigation district, say you get 1 acre foot of water per acre. So somebody's got to keep track of all that. They got to get the readings. You can either do it through instrumentation or sending somebody out and looking at it, but you got to collect that information. That goes into an accounting program. And next slide. You build various charts. This is an example of one of the reports we do. We've got about a half a dozen different reports for different purposes, but It happens at the city, it happens at the irrigation district, happens at the state level, it's all around. Technically, it just takes manpower and time. So anything that can be done to help facilitate and accelerate that process, that's helping us out. Technical side, or from the policy side, your water rights might depend upon it. Your loans with the government might depend on it. Your loans with a bank might depend on it. There's a lot that gets used by these records. So your records and the accuracy and the reliability of those records become important. Next step. Then the last slide. This last slide, I put it up here as fire and water conflict is what I was thinking, and talking about water rights. The last part I do is the defense of water rights. Lots of different interests and concerns about water. Everybody needs it. It's one of those essential elements that we have. Air, water, food is our priority. We can only last a few seconds without air. We can only last a few minutes without water. So it's one of those basic factors we got to have before anything else. And so everybody's looking for it. You have ag interest, you have urban interest, you have environmental interest, and trying to balance those interests in an optimized fashion is a challenge. And some people are more cooperative about doing that than others. So it is one of those challenges that we work forward, and I think that was my last slide. Oh, I got one more slide. Everything that I've talked about today has been about surface water, because my agency focuses on surface water. Next slide. Groundwater. All of these issues exist in groundwater as well, and groundwater is just as important to us, particularly in the valley, as anywhere else. It's our reserve. So it's essential that we keep an eye on that and understand that. And with that, I'm finished. I'll pass this along to Chad.
Thank you. I'm going to jump in really quick. We found a ID is Lisa Bath in this room? No? Okay, well, we'll keep looking for her. So anyways, we'll keep that here. And then, perfect. That's pretty much all I had to say. Hands it off, yeah.
Yeah, great. So thanks, Steve. My name's Chad Fisher. I work at the State Water Resources Control Board, the Division of Drinking Water. I'm a licensed chemical engineer, and I lead a work group of engineers to essentially the day-to-day is predicated on that people have a reasonable expectation that the water that they're served is safe to drink. So my day-to-day work has a very human aspect as far as water goes, because it's about human consumption. So I should sidebar and say that I'm also a junior FLL coach, so I hope that I have a little bit of a perspective about maybe what what you guys can glean here. And so I'll tell you a little bit about what I do, and maybe some of that will resonate with you. And then I'm also going to talk about maybe some broad categories to think about when you guys are thinking about your teams and your project, and maybe to prompt what you can prompt your kids with. So so again, the State Water Resources Control Board is a big agency, and I work in the Division of Drinking Water. And so you guys should understand probably what drinking water is, and so that's any water that is intended for human use. So examples like drinking water, like you drink it, but also showers, cooking, any of the water that comes into homes or comes into a business or comes into a park. That's all drinking water, okay? That's what the water industry calls it. So when I say drinking water, think about all of those uses. And so the Safe Drinking Water Act is a law and consequent regulations, statutes that again try to ensure that the water served to folks for domestic purposes is safe. And we should kind of define how people actually get that water, and they get it from public water systems. And so the definition of a public water system is a water system that serves more than 25 or more people, or 15 service connections. Again, I like examples. So it's something as large as the city of Los Angeles or the city of Clovis, and then all the way down to a rural park that has a well that goes into a few pipes, and there's some drinking fountains and a bathroom and whatnot. everything in between that, as long as it serves 25 people in a day, so even a Caltrans rest stop, that's a public water system, okay? So the Safe Drinking Water Act applies to all of these water systems, and again, it dictates that water should be safe to drink. And myself and folks like me in my office are really charged with ensuring that the Safe Drinking Water Act is complied with, i.e. that the water is safe to drink. So there's something that's not a public water system that we're all exposed to as well, which is we probably either know, or maybe some people out there have, they're on a private well. We also call these a domestic well. So somebody who lives in the country, they don't have a pipe from the city of Clovis doesn't run out to them and deliver them drinking water. They have a well in their backyard and a pipe goes into their house, and that's what they shower with and drink and whatnot. And so we call that a private well or a domestic well. And right now there aren't regulations around water quality for those wells except at the time of drilling, okay? So there isn't any ongoing testing that confirms that that water is necessarily safe or not. There's certainly testing available, but there isn't somebody like me ensuring that somebody has their well tested. Does that make some sort of sense? So I'm going to say public water system, probably a lot. So just think, serves more than 25 people, 15 or more connections, City of Clovis, park, rural church, rural school. Those are public water systems, okay? And so, again, my day-to-day is ensuring that those public water systems deliver water that meets drinking water standards, that is safe to drink. There's a couple other things that the Division of Drinking Water does, which I think are interesting. Certainly not everything that we do, but there's also a regulation development unit. So new regulations come along, and although I may not be a fan of lots and lots of regulations, certainly when there is a contaminant of concern that has a potential public health threat, we should develop a regulation around that. And so folks at the Division of Drinking Water do that, and I loosely call those emerging contaminants. And so I think that that's pretty interesting that, there's people thinking about things that may or may not be in the drinking water, and should we or shouldn't we start thinking about limiting that exposure for folks in drinking water? I think that's really interesting, probably more from a hardcore science stance, but also certainly from a public health stance. So we also are very involved in infrastructure projects, and the infrastructure projects are, again, for public water systems, and so you could think of that as a rural community has a well that we know exceeds the drinking water standard, so they need to discontinue use of that well, so there's funding available to go ahead and drill a new well and plumb it into your system. And so the Division of Drinking Water really facilitates that process with the water system, oftentimes with other consulting engineers, to kind of ensure not only will it, to ensure that the project will end up being a success, which means, deliver water that meets drinking water standards. I've probably said that 10 times. That's what I'm about. Water quality, delivering water that meets drinking water standards. So, with that, I'm going to spend a couple more minutes about some broad areas that I think that are in my professional expertise that kind of apply to First Lego League. And these are broad categories. I'm not going to tell you what I think you should do, but maybe the questions will take that form. So obviously you guys have figured out my professional world is about water quality, is about this reasonable expectation that the water is safe to drink. So water quality, I think that that's something that kids, that our kids should be thinking about. What is in the water? Is it safe to drink? How do we know it's safe to drink? What actually are we concerned with? Who decides that? I think that those are some good questions to ask. Water quantity is something that I deal with quite a bit, and so I deal a lot with small water systems. I didn't tell you, but I deal with and have dealt with water systems in Fresno, Kern, Tulare, and Kings County, so all over the Central Valley, and it's actually composed of like about 2,000 water systems, which is, it seems like a lot when I say it out loud. There's about 7,000 statewide public water systems, so a lot. But many of these small water systems deal with water shortage. So either that they have a well and it makes water, but just not enough to supply everybody, or that, you know, maybe that they have a well and the well has gone dry or something like this. And so I think that water quantity issue is something to think about, not only on a water shortage side, but you can also fold in conservation there. How much is enough water? You know, what are reasonable conservation measures? How much water do we use for outside versus inside the home? Because everybody should know we water our lawns with the same water that we drink, right? So I think probably because of the drought, this has really been sunshined, and maybe people didn't understand that before, but there is, I mean, we could think of that as a competition, right? Like there is a competition for that water. Another area that I think is interesting, and for me it folds into water conservation a little bit, and Lisa may end up talking about it a little bit, but Division of Drinking Water is involved with recycled water. So we see signs here around Clovis that are purple, and they say, and actually the pipes are purple, we call it purple pipe, so that's recycled water, and that is water that is wastewater that has been treated to a high degree and then can be used to, most of the time, irrigate outdoors. And you know, it depends on the level of treatment, what you can actually use it for. So if you don't treat it very much, you may only be able to like water cotton with it, okay? But if you treat it to a quite high degree, you may be able to water the grass at a golf course, okay? So this recycled water use is really taken hold and in use a lot in Southern California, because traditionally they've been more water short, or maybe had a more palpable understanding of the value of water. And I think that is penetrating the Central Valley, and water systems that are able, like the city of Clovis, kudos to them, are understanding that that's a pretty critical part of their water portfolio. So I'm going to stop there, hoping to leave time for questions, but I'd encourage everybody to think about drinking water, about what sort of ideas, what sort of projects your kids can use to, or can identify to improve something about the drinking water system. And again, I hope something that I've said has resonated. So thanks.
Hi. I'm a graduate of Fresno State in civil engineering, and I'm a registered civil engineer. I'm also a distribution water operator. A little bit of background on the city. Prior to 2004, the city of Clovis only utilized groundwater for our water supply. Then we had done a master plan in the late 1990s, and we were looking at the sources of water and how we were going to be able to plan for growth. And we determined that we needed to do a conjunctive use, which meant that we needed to use more than just groundwater. We needed to use surface water, and then ultimately recycled water, so that we could meet all of our needs. So in 2004, we built a surface water treatment plant. It was originally designed at 15 million gallons per day. And then over time, we developed, prior to 2009, all of our wastewater went to the city of Fresno for treatment. So we decided we were gonna start treating some of our own wastewater and creating recycled water, which we can use then to take the burden off of the potable water. So we have that plant. It was completed in 2009. We're able to treat up to 2.8 million gallons per day, which is about a third of our production, wastewater production. We use that water to irrigate landscapes, public city-owned landscapes. We provide water to the Clovis Community Medical Center. We also provide it to Caltrans. They use it to irrigate Freeway 168. And we have a farmer adjacent to us who also takes some of the water, some of the excess water that we have. Because the demands are much higher in the summertime, the system is designed so that any excess then is discharged to Fancher Creek. So we try to minimize that. We try to find as many uses for it as possible. Our surface water supply is through an agreement with the Fresno Irrigation District. As the city grows and we have more land that's within the irrigation district, our supply of irrigation or surface water increases. We use that water for two purposes. We use it for the surface water treatment plant, and then we also use it for recharge. We have a recharge facility, a groundwater recharge facility, which is located at Marion and Sunnyside Avenues and Alluvial Avenue. And we intentionally put water into that facility to recharge the groundwater so that it'll be there when we need to pump it out. We also utilize surface water at flood control district basins. And that, the disadvantage to that is it's only available in the summer months when they're not being used to collect storm runoff. But it's an efficient use of holes in the ground, so to speak, so that we can continue to put the water back in. Our objective is to balance our water use with our water supply. The water that is delivered to our surface water treatment plant comes from the Enterprise Canal, which comes from Pine Flat, Kings River water. We have a requirement from the state that we need to patrol the Enterprise Canal on a daily basis to make sure that the water quality that's coming down is protected, that there isn't a truck in there or somebody hasn't contaminated the water. And so we have somebody who drives up and down the canal every day, 7 days a week, every day that we're running the plant. One of the issues with that is that's a little bit of an intensive effort. At one time we looked at having the county, they have the sheriff department does some flying and having them kind of patrol it, but they can't really get close enough to see it. So one of the things that we're looking at right now is perhaps using drones. So that's one of those things where you try to look at, is there a technology that will help you to do things a little bit more efficiently to protect the water quality? For the city, one of the two things that are big issues for us are supply, the variability of supply that can happen on the Kings Basin. Some years the supply is kind of short, like it was during the drought. And then this year we've got tons of water. And so one of the big things is trying to find places where you can put that water in years when you have excess, so that you have it in the years when there are shortages. The other issue for us is quality of water. Sometimes the quality of the water can be impacted by color, depending on where they're sending the water from. And then sometimes the quality of the water can be impacted by taste and odor. And when we get taste and odor issues at the plant, we try to treat that by adding powdered activated carbon to eliminate the taste and odor. Other issues that we have to deal with are contaminants that are in the water, like in well water. We have issues with DBCP, TCP. You could have manganese, which is naturally occurring. So you have all these different contaminants that you have to deal with and provide treatment for. We're constantly doing monitoring of our source waters. We're required by the state to do monitoring on a regular basis. And then every few years, the Environmental Protection Agency requires us to participate in what they call unregulated contaminant monitoring. We'll be starting the next round of that, round 4, this coming January. And what that means is that they will require us to do monitoring of all of our water sources, and then they look at all the data that they gather from all the water systems that supply that data, and they determine which contaminants are occurring at a rate that they're going to develop regulations for. And so then down the road, new regulations will show up on what we have to start testing for, and if we have a problem with it, then we have to provide treatment or not use the source. So that's kind of an ongoing thing for us. Conservation. Obviously in 2015 we were put under great requirements for conservation, and our customers stepped up to the plate and did a great job doing that. But that's a challenge for us, is trying to meet the requirements that the state indicates on how much water we can use. There's new regulations that will be coming down eventually that will limit. Right now the regulation is that by 2020 we have to be down to 199 gallons per person per day. That's probably doable, but the future they're going to be having regulations that will limit us to perhaps 55 gallons per person per day for indoor use, and an amount to be determined on outdoor use. So that's another challenge for us, is how do we get our customers to do it? I mean, we provide the water, but they're the ones that use the water. And so we have to try to help them to meet those requirements. I guess that's probably, there's tons of stuff to talk about, but let's get to questions. Huh?
So now we will segue. I know it's almost lunch. Yes, thank you. Thank you. I am going to keep you guys here for a little bit longer. I think lunch goes until like 1:30, so we kind of plan that so this session always goes over. So you guys can get a lot of really good questions in. Please do stay seated and be respectful so we can all hear, because these questions will be really important for you guys all to answer. Couple things. We provided the Kings River Handbook. There's a whole bunch over here, so thank you so much for doing that for us. So after this, when you guys leave for lunch, feel free to grab one. And I think with that, I did want to really quickly, before we jump into questions, I know, of course, this is typically geared towards the project, so really quickly, just for our panelists' sake and your sake, I'm going to run over really quickly. The project challenge for hydrodynamic season is to improve the way people find, transport, use, or dispose of water. These might include everything from quenching your thirst to swimming in a pool or lake. Water might be part of the process used to produce your food, energy, mobile phones, or other products. You probably use water in ways that seem too small, boring, or gross to even mention, like flushing the toilet. But all of these uses are part of the human water cycle. So just to make sure, keep our questions kind of based around human water cycle. So anybody have questions? Go ahead and raise your hand, and I will bring you a microphone, and then we can have our panelists answer, if anybody has any questions. Anything at all.
What are some recent changes in emerging technologies or the way we think about using water that are interesting to you?
One that I stumbled upon in the last year that's kind of interesting, well, there's a couple, because we have an incubator and we're seeing all different kinds of new technologies coming down the pipe. Two areas, I would say. One is more environmental controls. There's a new technology that's now being used to kill off harmful algal blooms. Every once in a while you hear about somebody losing their pet because they've licked water that has an algae that has grown in it that has a very poisonous contaminant. One of them is microcystin, for example. Domoic acid is another. But they're using ultrasound. And the technology limitation is that it can only cover a certain area. So you got a bit of a limitation if the algal bloom gets really, really big. And algal blooms affect not just fresh water, but ocean water. There's been animals that have washed up on the beaches in California. So it's a very difficult one, but the monitoring of it, testing of it, all those things are ripe for new technology. That's a new problem. The other one that's really big these days is treating to remove salt. The biggest technology that's out there and has been used for some time is called reverse osmosis. Okay, and what it does is it pushes water through a membrane that's porous to the size of water, and the water comes out, the salt stays in and gets rejected. Well, now we've got all kinds of other technologies that have been around for a while. They're trying to scale down in cost because agriculture can't afford the cost of desalination that they're paying for in Southern California. There's a big plant down there, and they're planning another one, the one in Carlsbad, and now a new one in Huntington Beach. It's about $2,100 per acre foot. Farmers in the valley have only been used to paying, in some cases, only $30 an acre foot. Those are more water scarce. $250, now pushing $500. So you have to get the cost down to between $250 and $500 per acre foot. We've seen some that are more related to electrochemistry that are now getting down into those cost levels. The one problem is still, especially here in the valley, what do you do with the reject brine? Because if you concentrate it and it has some of those bad things I mentioned very early on in it, it becomes a hazardous waste. And so that's the other breakthrough that we need, is to figure out how to manage those harmful chemicals that might be left in the reject. So we're on the verge, though. We just had one of these deionization units that's going to be set up to use oil field wastewater down in Kern County, pilot project. I also met a PhD researcher from Berkeley who's using one called capacitive deionization. So the good news is that the chemistry and the cost, because of new materials and very good research, are going to be driving those costs down much closer that even agriculture can do. So it's a very ripe area for looking at and figuring out what it is that we can do, and requires a lot of sensitive monitoring, by the way, and sometimes the monitoring can't keep up with the technology for treating. You got to know instantaneously almost what's going on.
I want to hop in really quick and say it's really good to use these ideas as a sounding board, but make sure when your students are thinking of projects, it is very important that they do the research to make sure that the projects that they're doing don't already exist in function, in society. So as deeply, and in part, I think actually the project rubric, if you guys were on my session, did change this year. And so that is stressed even more, is really do the research to make sure the idea that your students have thought of isn't already happening right now in California or anywhere, that it is an innovative solution. Now, if you can really tell the judges, only in the last week we learned, but we really tried to do research and couldn't find it anywhere, and only really recently learned, that's one thing. But from the get-go, please keep in mind for your rubrics that it shouldn't be something already happening. Use these as a sounding board.
Is it okay to improve on existing technology?
So it is okay to improve on existing technology. So it must definitely be, and so you can improve it, and it really needs to be, an innovative way to improve it. So yes, this is pre-existing, but we can make it better in an innovative way, not something that's, we're already improving it this way and don't just jump on the bandwagon. If it's pre-existing, but we make it better, that is innovative in and of itself, and that is fine, yes.
You were talking about monitoring, and I know second gentleman here as well was talking about that in accounting for the uses and how you're managing that. Were there any challenges to accuracy as far as the accounting of those things, and making sure that people use what they use and all those kinds of things, that from a technological perspective there's challenges there that you guys don't have the resources to be able to do that?
Accuracy is always a challenge. The best designed instrument has inaccuracies. We talk about the lab results in chemistry. They're down to parts per billion, parts per trillion. I don't know what unit they might be down to now. There's always room to go a little further. A lot of surface water measurements are considered excellent measurements at plus or minus 2%. That's pretty good under most considerations, but there's always room for improvement. So there's lots of opportunity there.
And I want to jump in really quick. It's really prevalent in this whole water story is how much everything costs, because water is so important to everyone. On the new project rubric, it is actually very important and stressed now that if your students want an accomplished or an exemplary circle on the rubric, that they take into account the cost of the project. That perhaps, of course, you or your students might not know, but if you can talk to a professional and say, this is our idea, how much does it cost to implement this? What do you think if we wanted to do this crazy idea? How much will this cost? Perhaps the effort that humans have to put into it, the technology that costs, the cost to maintain it, how effective will it be? Really scope it out as if, your students are real adults wanting to build this now. Those are key things that when you go to talk to your topic experts, ask them about that, because that is new on the project rubrics.
Yeah, I've got one to add on to that. I mentioned the snow sensors here. Reliability of those is a huge issue, and the economic consequence of not having that data. I think they say the flood control system in California protects about $2 billion or something like that of real estate. So not having that data, you're putting huge costs at risk. To go up and maintain one of these stations right now took one guy 70 hours, 56 miles on horseback in a week. When you add all that up, that's about a $20,000 bill for 4 hours of work. So anything you can do to create the reliability and reduce that and improve the accuracy, those are the kinds of things you can start looking at economics. They're not your common economics you might think of, just the cost of the sensor. What are the avoided costs you might have?
One area that's really ripe in the water industry for all of you to consider is visualization tools. We are data rich, but information poor. And a good example is what Lisa talked about. If we have to go to 55 gallons per person per day in our houses, how do you know where you are on that water budget? We have no, right now, easy visualization tools to tell you you've gone through that much. It could be a dial, but it could also be something that you just pull up on your iPhone. And there's people that are working that area, but I'm telling you, it's ripe for a lot of activity.
So cool. Anybody else have any questions? Anything at all, it'll help everybody else here. Perfect.
So what about the idea of, let's say there's a program that's being used in a different state, but it's not being used here locally, or maybe not being used, for example, at the child's school, and it's something that could be implemented. Would be looking at the details of how to get that budgeted, financed, and doing a project on that. Would that be appropriate?
So you're saying somebody else is already implementing it somewhere else, but you want to look into the specifics of bringing it into your community or your school? That gets a little touchy, because the solution, so you would have, at that point, your team would have identified a problem, and then you want to bring it, the solution to it, to your, even if it's say it's a problem at the kid's school, they identify it, they need a solution for it. If the solution you found is just one you see working somewhere else, you grab it, implement it. Now the implementation to get it at your school, I understand, is different, but that solution itself is not innovative because it is already somewhere else, but you're bringing it here. If your team could take that solution and improve it, change it, be like, I like what they did, but we could do it better. That would be fine, but just taking it and moving it, I would say, gets you into some very touchy territory, and at this point, I would say, early enough in the season, I wouldn't recommend it. Would making it more cost-effective consider making an improvement? Huh. I guess in a way that's an improvement in cost, especially because cost, especially with water, is so important. So it could kind of, you could pitch it that way. But I guess it depends on how you make it more cost effective. If it's just the same exact technology, but you write a grant for it to make it cheaper, that's not necessarily innovating the solution. It's writing a grant, which is not a bad thing. Grants are great. I'm not saying anything against grants. But the solution itself, if you find a way to innovate it to make it cheaper, yes. I'm going to go ahead and say yes. But if it's just, well, you get what I'm saying. But good idea.
So piggybacking on that, so basically finding some, or the kids discovering or researching new technology for a particular purpose, but then repurposing it for a new purpose, that would be innovative, right?
So you find a technology over here, repurpose it for a different thing? Huh. Interesting. I mean, that's what I like about this sounds silly, but what I like about the project is it is very broad. As you can tell, I'm basically basing most of what I'm saying off of a couple sentences in the challenge manual. If the kids can really show the judges that, we identified this over here, we can improve it to make this better, this problem over here, and as long as it's not the exact, what I just want to prevent is just, oh, there's a solution over here, copy paste. I don't really like that. I understand that it's two different situations, but I would say to be safer, as long as they change something about it, improve it, that would make it okay. And so you could kind of start, be like, oh, well, this is working over here. We could tweak it, improve it, place it over here, use it. That's fine. I think besides that, you walk too much of a fine line. And it is very open, so as long as your kids pitch to the judges, like, yes, this is used over here, we tweaked it, now it's making life better over here, and you really can stress, look at the rubric for innovative solution, and if you guys can really tailor it to that part of the rubric, then I say you're fine. And we really don't, definitely in judge deliberations and whatnot, we do really kind of, grasp at straws if it's close. It's fine. We're not here to be, we don't want to disqualify people. We don't want to, these kids have worked so hard for weeks on their project that we don't want to bring down their day. So as long as it's close and we can see that it's a little bit innovative and that you've solved the problem, that's good enough in my book.
So a quick question for Lisa. For City of Clovis, how is data collected on the residential water consumption? Because I know every house has a meter, but is that like visual inspection or wireless, or how does that work?
Okay, so we have two methods. One is just direct read, so about probably 20,000 of our meters are just direct read. So you go out, the meter reader reads it every 2 months. The other ones have a radio transmitter, and so it's kind of the same thing, except for we don't have to actually look at it. We just drive by or something and we can get the reading. In the city of Fresno, though, they have an automated system where they have data collectors throughout the city, and it can collect the information on a pretty much continuous basis. I'm not sure if it's every 4 hours or every 2 hours, but they can collect it pretty frequently. We haven't gone there because it's pretty expensive. It's a very expensive proposition. So it was a little bit different for Fresno because they didn't already have meters, and so when they went ahead and finally got meters, it was kind of a, well, we may as well go this way so we don't have to hire all these meter readers. And we only read our meters every 2 months. However, a customer can go out and read their meter every day if they want. And there is, all the meters have low flow indicators on them, which are little red knobs or black, that will show when water is flowing, even at a really low level, so you can tell if you have a leak or something. But yeah, customers can go out and visually look at them.
Hi, we're not affiliated with a school, so we were wondering if any of your organizations have any like field trip opportunities for kids to come in and observe what you do.
Yeah, Ken and Lauren brought some kids in from Dry Creek and Alta Sierra just a few weeks ago, and we have our wet lab. If you make arrangements, and we know ahead of time, well, we show them all of our facilities, and we can give a little talk in one of our conference rooms. So we do that at Fresno State. So I'll leave my card.
Ours, not really. Ours would be like going to the principal's office. It's not that interesting in our office, so.
So likewise, Division of Drinking Water is available, but it's coming into the office and it would be listening to somebody talk about what we do, maybe looking at some databases.
We do tours out at the water reuse facility, our wastewater, recycled water facility, and at our surface water treatment plant. Usually you just contact me and I'll set it up.
Well, we'll take one more question, and then I think we will be released to lunch, and so we'll take this last one, and then I'll have a couple last words, and then you're fine. We'll let everybody.
Hi. I wanted to know, what would it take to bring gray water systems to all the elementary schools? Or not just elementary.
Any schools. What would it take to get gray water at any schools in the area?
Okay. Well, I'll speak up a little bit. Okay, you're talking recycled water. Recycled water and gray water are different things. Gray water is wastewater that doesn't come from the toilet, comes maybe from your kitchen sink or your bathtub, and it's used untreated. And so I think that building codes may allow that. As far as getting recycled water at the schools, they can. Generally, they have to work with the city. It depends on where they're located. If they're located in an area that is adjacent to our transmission mains, then they can. They'll work with us on getting some plans together and stuff like that. And the advantage to them using the recycled water for their landscape irrigation is that we sell it at a discounted rate. It's quite a bit cheaper. So, and in fact, Clovis East is pursuing it.
Okay, thank you so much, everybody, for coming, whether you're attending or a panelist. Thank you. Make sure you guys pick up your pamphlets over here. Also, please remember, we do have a food truck out there that gives part of the proceeds back to us. So enjoy lunch. Come back in a little bit.